We've already talked about what it is to be a limiting reactant or a limiting reagent and what that actually means. So I'm not going to discuss the actual definition of what a limiting reactant actually is, but what we'll do is we'll go through a sample calculation. In this example, we are given a balanced reaction. We have acetaldehyde. We have 2 moles of acetaldehyde, CH3CHO, with the addition of oxygen gas to yield acetic acid. So we have HC2H3O2, 2 moles of that. We have our balanced reaction, which we're going to start to work with. Now, in these limiting reactant problems, we're going to be given some sort of amount and then asked how much reactants are required in order to produce so many moles or so many grams, or vice versa, how many moles or grams are required in order to produce X number of moles of acetic acid. So here's what we're given. We know that we have a starting amount of 20 grams of CH3CHO, or acetaldehyde, and we have 10 grams of oxygen. So for this example, we are asked 2 questions. A, how many grams of acetic acid can be produced? So how many grams, I'm going to abbreviate it, acetic acid, can be produced? And that's, using 20 grams of acetaldehyde and 10 grams of oxygen. And secondly, how many grams of excess reagent remains? So how many grams of excess remain? And when they're asking about how many grams of the excess remains, we have to keep in mind that one of these is going to be used completely, well, in theory, is going to be used completely to make this acetic acid, and then one of these 2 is going to remain in excess. So the question now is well, how much of that is there? The first thing that we need to do is we need to calculate which one of these, or which 20 grams or 10 grams, which one of those is actually going to limit our production of acetic acid. And in order to do that, we need to go from grams to moles to moles. So let's start with what we know. We know that we have 20 grams of acetaldehyde, and we know that we have 10 grams of oxygen. So we're going to do this simultaneously. We're going to convert from acetaldehyde to moles of acetaldehyde. So again, we need the molar mass. So 1 mole of this substance, CH3CHO, weighs, and this is approximate, 44.1 grams, CH3CHO. We've seen earlier and before that we've got something in the numerator, something in the denominator. Those will cancel. We'll be left with just moles. So that's nice. And then we need to convert from moles of acetaldehyde to moles of acetic acid. From the balanced equation, looking back up here, we notice we have a 2-to-2 ratio, or in other words a 1-to-1, but we'll go ahead and write 2-to-2. So 2 moles of acetic acid are produced for every 2 moles of acetaldehyde that get used, CH3CHO. Okay? And we'll do the same thing with oxygen. Convert from grams of oxygen into moles of oxygen, so 1 mole of O2 weighs approximately 32 grams. Again, we see that these cancel, we'll be left with moles. And now we need to convert from moles of oxygen into moles of acetic acid. So we set up our mole ratio, moles of acetic acid over moles of oxygen. Looking at the balanced reaction, we see that 1 mole of oxygen is used to produce 2 moles of acetic acid. So 2 moles of acetic acid for every 1 mole. Okay? And then when we actually do this calculation, we find out that we can make from the 20 grams 0.454 moles of acetic acid. So that's from the 20 grams. And then from the 10 grams of oxygen, we can make 0.625 moles of acetic acid. So we look at this and we go, okay, which of these two is the lesser amount? Well, it turns out that 0.54 is smaller than 0.625, so we know that this 20 grams of acetaldehyde is our limiting reagent. Okay? So what we need to do is we need to continue on this calculation. We say that at most we can make 0.454 moles of acetic acid, but we need to know how many grams. We're asked to find grams. We're almost there. We just need one more quick conversion. So we start with 0.454 moles of acetic acid and convert that over to grams. We say that 1 mole of acetic acid weighs approximately 60.1 grams. Notice that moles and moles cancel. We're left with grams. When we do this calculation, we should get 27.3 grams of acetic acid. So that takes care of part A. Now the question is, how many grams of the excess remain? So we know now, or we have found out, that oxygen is the one that's excess. So the question is, how much did we actually use to produce this 27.3 grams of acetic acid? Well, we always start with what we know. So this time we're going to go from moles of acetic acid backwards to moles of oxygen. We said that at most we could produce 0.454 moles of acetic acid. So again, starting with what we know, and this is part B, we're starting with 0.454 moles of acetic acid. We're going to convert moles of acetic acid to moles of oxygen. So, moles of oxygen, we want that in the numerator. We want moles of acetic acid to cancel. Looking at our original equation, we know that 2 moles are produced for every 1 mole of oxygen. So 1 mole of oxygen, every 2 moles of acetic acid. We do this calculation, and we end up getting 0.454 divided by 2. We get 0.227 moles of oxygen. Oops. Okay, so now that we have moles of oxygen, we can convert over to grams. So 0.227 moles of oxygen. We need the molar mass. So 1 mole of oxygen weighs approximately 32.0 grams. We end up getting 7.26 grams of O2. But we're not done just there. We said we used 7.26 grams of oxygen in order to make this 0.454 moles of acetic acid. But we didn't have 7.26 grams initially. We initially had 10 grams of oxygen. So the amount that's left over is simply the difference between those two. So the original amount of oxygen, 10.0 grams of O2, minus how much we actually used, 7.26 grams of oxygen, and we should be left with 2.7 grams of O2 in excess. What's left over, what has not been used.